Let's talk about dipole moments and fields. So here I have a magnetic dipole and an electric dipole. The magnetic dipole is just composed of a little bar magnet, and the magnetic field is going to emanate from the North Pole, loop around, go back into the South Pole, travel through the magnet, and come back to the North Pole. The electric field lines originate at the positive charge and go towards the negative charge where they end. So both of these things, the little magnet and the little positive and negative charge, are dipoles. And the dipole moment is just a little vector. It's just a little vector that tells us how the dipole is oriented. So the dipole moment is not a field. Dipole moment is not a field. There's been some confusion about that. So it's just a little vector that we use to keep track of which way our dipole is pointing. So for the electric field, the dipole moment is called P, and it points from the negative charge to the positive charge. So if I draw it on here, it goes this way. And you'll notice it's in the opposite direction of the field, but the dipole moment is just a little vector that we use to keep track of the orientation of our dipole. For the magnetic moment, the magnetic dipole moment points from south to north. So that's with the field inside the magnet, but against the field outside the magnet. But why would we choose to orient our dipole moments in this way? Well, if we do it this way, there's a very nice property that when we put a dipole in an external magnetic field or an external electric field, so here's my little magnetic dipole moment in an external B field, this magnet is going to want to turn, let me use a different color, it's going to want to turn this way to align with the field. So when the magnet is in its lowest energy configuration in this external field, the magnetic dipole moment will point in the same direction as the field. And the same will be true for the electric dipole moment. This is going to want to rotate until the little electric dipole moment points in the same direction as the field. So the take-home message here is that the electric dipole moment and magnetic dipole moment don't point the same way as the field they produce points because they're not fields.